Hello everyone, Dr. Matt Ed. Today we'll talk about point-of-care ultrasound velocity time integral. Velocity time integral, also known as VTI, is a Doppler ultrasound measurement of blood flow. It is the area under the velocity time curve, and it gives you how far blood travels during a certain time period. If you multiply the VTI with the cross-sectional area of a valve, you get the stroke volume, which can be used to calculate the cardiac output. Left ventricular outflow tract, LVOT VTI, can be incorporated into a POCUS examination to determine the etiology of shock. Recall, cardiac output is calculated by stroke volume times the heart rate. And the stroke volume is the area of the valve times the VTI. Using the aortic valve, and therefore the cardiac output across the aortic valve, you can use the formula stroke volume of aorta equals area of LVOT times VTI of LVOT. To determine the VTI, you have to first get the chart in a 5-chamber view. So this is remember this is RV, this is LV, this is right atrium, this is left atrium, and this is the LVOT. And then you press the pulse wave Doppler button on the ultrasound, and you get something looking like this. And then you move the gate of the pulse wave Doppler right before the aortic valve and the area known as the left ventricular outflow tract. Then you'll get something looking like this on the screen. Here on the y-axis is the velocity, and the right axis is time in seconds. And since blood is flowing away from the ultrasound probe, you have negative velocities going across the gated area that you put your pulse wave Doppler on. On the ultrasound machine, there should be a calculation button where it will allow you to trace the area under the curve, and the ultrasound machine itself will calculate the VTI for you. So a normal value for LVOT VTI is typically greater than 18 centimeters. To calculate the cardiac output using VTI, you also need to measure the LVOT diameter, and this is done in a parasternal long axis view. You have the heart in systole, and you measure the LVOT diameter. So normal LVOT diameter in adults is approximately 2 centimeters. Here is an example of how to do the math to calculate the cardiac output using the VTI. Recall, cardiac output equals stroke volume times heart rate, and stroke volume equals area of LVOT times VTI. So using the flow across the aortic valve, we have to calculate the stroke volume across the aortic valve, and that equals area of the LVOT times VTI of the LVOT. Recall, normal LVOT diameter is about 2 centimeters, and normal LVOT VTI is about 18 centimeters. So to calculate the area of the LVOT, we take the LVOT diameter, divide that by 2, which will give you the radius. So that's 1 centimeters, and 1 squared times pi, which is 3.14, gives you 3.14. And you multiply that by the VTI, which is 18, gives you 57 centimeters cubed. This pi squared is the area of a circle. And then this VTI tells you the distance the blood travels in a certain amount of time. So if you multiply the area of the circle times the distance, which pretty much gives you the volume of a cylinder. And if you think about it, the aorta itself is kind of like a cylinder. So that volume that was ejected in one heartbeat is pretty much the stroke volume. So stroke volume equals 57 centimeters cubed, times that by the heart rate in a normal person. 60 to 100 is the normal heart rate. So you multiply this by the heart rate, gives you about 4,000 cc's, and that's about 4 liters per minute, which is a normal cardiac output in a person. If you thought this video was helpful, please like, subscribe, and look out for my next video. Thank you.